work with for the next couple of minutes. I need you to take out your calculator and working with that person and only that one person, show me what you can do with this first one. You have 5 minutes, go as far as you possibly can. Do all the things that you would do if this was the take-home quiz.
Yeah, I got it yesterday. Me too. That's a good thing. It's like nothing to
Alright, so let's start off by drawing. Well, we know we're gonna have to go through.
So if anyone's having a struggle of a start, my advice always, sketch the region.
Is it
Make
calculator right?
It's, oh yes, indeed, this one's calculator active. I should have made that clearer. Sketch the region. Make sure you know what you're looking at. Make sure you know where your axis of rotation is. And then probably the most important question that you're going to ask yourself after you've sketched the region, the most important question that you want to ask yourself, is it a solid object or is it a hollow object?
Let me see. It's like this. Yo, I got the same graph.
Yeah, and if you guys have calculator issues today, let me know.
Yeah, it's like that. So what is it? And then, alright, so let's draw it.
Y equals -3. It's under.
No, but there's also the vertical line. Don't forget about the vertical line. Mr. D, how would you put in vertical lines? Can you like backspace the X and change it to Y?
There are ways to, you mean in terms of like getting it on the graph?
Calculate.
It's not really that important. I mean, you could just like mentally put them in there. There is a way to do it, but I'm not going to waste your time. Okay. Edgar, you doing okay that this is the region?
Mm-hmm.
Okay. Next important thing, where's the axis of rotation?
Y equals -3.
Y equals -3. That's going to put your axis of rotation down here. Mariah, if this is your axis of rotation and that's the region, hollow object or solid object? Hollow object or solid?
Hollow.
Oh.
Mariah, which one? Hollow or solid? Hollow. Why? Okay, thank you for the honesty. Jennifer, help her out.
Because you have the gap between where the region is looking for.
Here's your axis of rotation, or axis of revolution, depending on how you want to describe it. Here's the region. The question that you want to ask yourself, is the region touching the axis of rotation? No, so it has to be hollow. So as soon as you've identified that it's hollow, we need to be thinking, oh, this is one of those big R squared minus little r squared kind of situations. All right, great. So, big R. Big R, we're starting on your axis of rotation and you're going all the way up until you hit that outside curve. Jonathan, what's big R? F of x minus -3. Top minus bottom. F of x minus -3, of course, you don't have to write it as f of x minus -3, probably what everyone's going to do. F of x plus 3. Edgar, what are your thoughts on little r?
Little r is f of x minus g of x.
Wait, little r starts
Oh.
on your axis of rotation and
My bad.
goes to here.
It's
So how long's little r?
G of x minus plus 3.
G of x minus -3 or g of x plus 3. Now I think you guys yesterday did a great job, and this just seem to work really well. We know that your setup is going to be pi. Oh, that's a dead marker. Okay, pi. Integrating. Where do we integrate from? Where do we stop? Oh gosh.
-2 to 3.
Right, if these are my vertical lines at -2 and 3, I'm integrating from -2 to 3. What am I integrating?
No. F of x.
It's big R.
Big R.
It's
So the
big
F of
R
x.
squared. So big R we just said was, where'd big R go?
F of x plus 3.
F of x plus 3 squared. Integrate that, right? That basically says pretend the whole thing's solid. Minus, give me another integral. Jose, what's the next integral going to be?
No.
There's going to be a pi, yep. Good reading. Tell me about the rest of this integral. We already handled big R squared, right?
Yeah.
So pi
G of x
g of x plus 3 dx. You're going to get me there one step at a time, aren't you?
parentheses.
Parentheses. Please, God, say squared next.
Squared.
Squared, yes. Okay, last thing is what are your limits of integration? You're going from -2 to 3. Honestly, how many of you guys had that as your answer? Okay, we're in a good place. Last thing I care about, what's the number value? Okay, this is probably 2 or 3 points worth of stuff on the AP exam. I just want to make sure everybody can type this into their calculator in one step and get me an answer. So take a minute, show me what you got. I'm especially interested in the 3 of you with our calculator going yesterday with you. I don't agree. You got it, just let me know. No, not quite. Wait a second. -2 plus 3 square feet. Look at what is on the paper and what you type. Okay, so a bunch of things that I'm seeing right now. Folks are typing in f of x, but not f of x plus 3. You need to make sure that plus 3 is getting part of the square. I'm seeing some folks that are dropping their pi's. They're forgetting to multiply the integral by pi. Some folks, the lower limit isn't -2. For whatever reason, it's becoming +2. Okay, I like it. We're good. Nice. Love it. Love it. Okay, we're 4 people, 5 people. Not in love with that. Not in love with that. Not in love with that. Not in love with that.
I'm actually getting mine back.
52.
When did you get it?
All right. All right, friends. If all goes well, you should have 352.368.
Yes.
I just did a lap around the room. It seems like half the people have 352.368, half don't. I want to pause on the calculator stuff just for a little bit. Just for a little bit, to get a little visualization.
It'll be outside the x, right? For sign.
How do we say highly? Or like I just said
Like how they always send like the things in folder. It has like your final.
All right. All right, so if you guys could stop the calculator just for a second. I always want to keep pushing the visualization. So that's the region that we're looking at. Axis of rotation is down here. My limits of integration are not exactly where I want them to be. They're about as good as I can get. So here's the revolve. Just so you can help get a better understanding of what this is looking like. So there's the revolve. Okay. Is everybody okay with hollow?
Hello. Toilet
If
paper.
you've got it in front of you, easy to see hollow. Right, the challenge is you don't get to use something fancy like this in the middle of the AP exam. You need to start to internalize it. If you sweep one disc / washer, right, that is, we're looking at those rectangular slices, all those rectangles as they're spinning. If I were to slice this object, if I slice it right down the middle, what you'd see is this guy here. We're okay with that? Right, your axis of rotation goes right here through the center. When we talk about big R, you're going from the center to the outer curve. Little r, you're going from the center to the inside curve. So there we are. Now, can you hit accumulate? Click on accumulate. Oh, I know. No. You go back up here to the arrow. No, wrong beer. There you go. Accumulate. And so this will just show you like all those slices, adding them up, adding them up, adding them up, adding them up. If you want to see, the last thing I want to show you is click on this show answer. And I want to draw your attention to what's happening down here. This is like what their setup looks like. This number that keeps increasing is what is the volume if you start here and you keep going all the way across. All right. And last button for you to hit, Ron B, or move X to B. Nope, move X to B. And if all goes well, when we finally get to B, this says 354.569, which is not the answer that anybody has. The issue is I'm not able to set my limits of integration exactly at -2 and 3. It's -2 and close to 3. That's why we're off by a little bit. Questions about the visual? All the friends are okay? Okay, so here's what I want to do. I want to give you guys the next 15 minutes, just get some good practice time in. Ron Beer, thank you. For those of you that are not getting the 352 point whatever number, we're going to go meet over there with your calculator and figure out what's going wrong. We've got to get the number right. For everybody else, I've got 5 problems that I want you to work on. The goal is to complete 3 of these. If you look on pages 2 and 3, there are 5 problems that get progressively more difficult. Your goal is to get 3 of these done. I want everyone to at least make it to level 3. For those of you that feel like life is good, I've got this volume idea under control, feel free to start at level 3 and go from there. If you're like, no, I just need some practice, feel free to start at level 1. Let the cups do the talking. If you need some help, I'll come on over. I'll help you out. We're going to work on this till about 3:50. Lots of practice time. Start at whatever level makes the most sense for you. Folks that are having calculator drama, let's go meet over there. Jasmine, you okay? You got it now. You switched out a battery. Now it works. Okay, but Marvin, you're still having problems? Okay, why don't you meet me over there? Anybody that didn't get 352 in there?
-1 inside with the head.
Okay, that makes sense. Okay, everybody's good? Okay. There's a lot of work that you have to do to get the setup right. But the nice thing is there's like 2 or 3 points normally associated with that, and then 1 little point with coming up with the number answer. But I want you to be able to get that one. Right, your calculator's doing the heavy lifting here. I want you to get this point. Okay. Okay. Did everybody over here get to 352?
Yes.
Okay, so you guys are level 1, 2, 3, 4, 5. Good. All right, friends over here. Did everybody get 350? Okay. And
like,
It looks more. Yeah, it looks
so
different.
instead, I was putting the, it was like FX.
Is that a what?
And was the plus 3 in
It
that?
was in, so I was
Yeah, so it's f1 of x plus 3.
A while ago. Not a while ago. It was a while ago.
David? Okay. But you get the right answer on the calculator?
Yes, you're right.
It's gonna be the square root of sine of x minus y.
Then that's this. Maybe it's just this one.
Wait, hold on.
Are you doing number
So is it f of x minus 0?
Cosine of 0 is 1 or 0? Huh? Cosine of 0 is 1 or 0?
Sine of x.
1. I get 2
It looks like that.
So those
What did you call it? Oh, I think something else like, he's not that long.
It's just like sine of x.
So, what do you mean it's gonna be like, no, it's like
Yeah. Yeah, now that you've got it set up, I want you to finish this part without the calculator. Right, so I want you to get some practice now with it. Integrate, evaluate, simplify all.
I thought it was that art from yesterday.
No. Our start happened literally
The thing, the r squared is happening, honestly, all the time. Let me get my little. If the object is solid, then it's not like a washer. It's solid, right? And so you would find the center, and you would go all the way out to the outside and say, okay, there's my big radius. So there's like the r squared. You're only going to deal with little r squared if it's hollow, right? The donut, the Cheerio, the whatever,
add the x,
the torus.
1/2.
It's a
plus
torus.
2. That's 3. No. That's 5 over 2. I don't know.
One half of the 2 over 2. That's 2 plus 1 is 3 and then.
So that's that half.
That's very
No. Yeah, because you have to.
I got 6 over 2.
So that's your exponent. Then you get the.
Yeah, 1 over 1, 2, so that's 2 over 1, and then multiply times times C1. You're adding fractions to the number.
So the thing is that you do not know what the graphic sign is. Well, that's after you've done that.
Because when you multiply x1, it's like you're adding them. And you can't add a fraction with a number just like that. You have to do a fancy one. So,
Next
so
one's
that's
out.
5 times. So then it'll be 2 cosine 5 over 2.
So if 5, 2, you add the 1.
The antiderivative is also
So it's 7 on 2.
7 over 2. No, 2 7. 2 7 cosine 7 over 2. Oh, because you know when you do the antiderivative, you have to plus 1 with the exponent. So that's 5 halves plus 2 over 2.
isn't it? Is it like 1 half or 1 half?
You know, oh, okay, so I see what you did. So you know how you have 1/2, so you basically add the exponent, right? Because you're multiplying. Yeah, so it'll be 1/2 times 2.
Oh my god. Oh, I just threw up in my mouth.
No, it's plus
Here.
But in order to add them, you have to multiply. And this is actually
baby
so
bird.
you multiply all this times 2 over 2. You get 4 over 2. So they can have the same denominator. And when you add them, you get 5 over 2. And then since you're getting the antiderivative, you plus 1. And then you have to multiply
Is
with
it
1
hollow?
times 2.
Okay. So
Would
add
that be
one to
hollow if
nothing.
it's this?
Aha.
No, because it's just on the x-axis.
And you do the same thing. You have to do that for.
Because it's against these, right? That's correct.
So then it'll be 2 7ths cosine of x. Am I speaking to them?
It's not supposed to.
No.
I can really.
Nobody cares.
But your calculator.
He did all of that just to threaten you. I have video proof.
How you miss? Is she like right here?
Oh, this is tough.
But if it's
Because you're.
I know you're in
I think what happened is you changed your setting to radian.
You mentioned my skin tone.
But you know at the bottom it says like make
Way darker than
The sign of pi is.
okay.
okay, I get it.
Here, don't let the other
that
kids mess with your
What?
calculator.
mine.
She wound up switching your calculator back.
I should have started there.
And so I just went up and said, let's do that.
Just do it. Because I'm not, I don't know.
Do we keep the
No, like, when you
Okay,
did
friends over
it,
here, how we doing?
I get it.
Don't you plug in?
Oi, my God, so ugly. Not you personally. Okay, love the setup. Love the setup.
right.
All the points for the setup. Now, tell me what you're doing to go from here to here.
Did negative cosine.
And then did you square it? Yeah, and what happens if you take the square
Root
of the
of the
sine
square root takes out
Let's do that then.
Yeah, I just saw you down like.
of x? Square root of the sine of x.
I literally told you that
Don't
we did
overthink
it, but I
this.
circled it for you. Because I told you you were
Square
doing
root
it.
of square root.
Sí,
So then it'll be just cosine.
honestamente no sé.
What's the antiderivative of sine of x? Negative cosine.
You know what showed you?
You know this word for nothing.
Yeah, but then this is
So good.
Bro, I knew there was something wrong because I was way too complicated for a little one.
Honestly,
Zeros and
negative cosine.
oh, I thought like, why not? So then when you
Oh, then, okay, so from here on, it's easy.
Right, you've got a solid object there. All you think
What's that zero sign?
So let's look at what happened.
well, what?
So I like
That's
the,
only one equation.
okay, I like that. Oh,
Negative cosine of
I
pi
like that.
minus pi. Wait,
You can
right?
separate them, right? Into different integrals, if you want to.
Don't you plug in the n value?
But then that means talk about the whole thing.
Try it.
You have to enter the pi and the end.
Ooh.
It's pi times negative.
That's minus 2x.
Oh, there you go.
Oh, because you don't need the integer anymore, right? My bad.
And what do we know about this?
Then we get to square it. The entire thing.
We used to live that window.
So now you
This
got,
one. Yeah, pi.
so this the.
Oh, we go back to
I
x.
said that.
Wait, is 2x on top? What's on top? 2x is on top, right? Oh, yeah.
So,
So it's r plus wait, r squared.
How do you do, so what is that just the line?
Okay, friends over here, how are we doing? Good, I'm fine with you. Right, because at that point it's just
I think it's just like the same as like.
oh no,
Like, it feels
no.
like the gravel is just too wider.
Shame. You don't want me to banish her. Okay, love the region. Love the intersection points, all the things are good. When you find the volume, solid or hollow?
That doesn't have like a.
Is it hollow to this space?
Because the region that you're looking at doesn't touch the axis. So like when you have your
It spins like this.
oh, what am I trying to do? Right, there's the region.
We don't know the points of intersection.
You're spinning around the x-axis. So draw the reflection if you have to. Here's the reflection, and then we do this. If I were to draw my little rectangular slice, there's my rectangle. There's the reflection of the rectangle. Right, it's going to be hollow.
I got here, so what do I do?
But the important thing to keep in mind when you do hollow, we're thinking big R squared minus little r squared.
Yes,
Wait, so write it out.
Love it.
Yeah, we have no idea what you're saying.
Square root it.
Right, no, write the new, whatever.
Those are not
That's a wrap.
the same.
Yeah, because it's
To do big R minus little r squared, you would have to like do the box,
Yeah, okay, that makes sense. If that's
and you're not going to get the same value as this guy.
Alright, so write it out, bro. And put it in order. No, don't put the square, put the key first. Yeah. You should just factor it in.
Shouldn't we get a number?
Hey, distribute the negative x and we're gonna get the same thing.
Okay, friends over here, how are you?
Negative x.
It's basically what you did,
Okay,
but
so-
instead of doing
You're
it,
trying to find points of
because you
intersection.
did this here, you're just doing that.
Past the start of x squared. The other one, the way that you find points of intersection is normally you set the two points to each other, and then do some legal algebra.
With the x
Yeah, I see that in this paper too, and that's true, but that's so not helpful. How about, let's rewrite x squared equals 2x over 4. Subtract the 2x to both sides. So now you should have, oh my god, you decided to write it in the hardest way you possibly could.
Yeah.
How about x squared minus 2x is equal to 0? How am I going to solve that? You're going to factor, and you're going to set each factor equal to 0.
You got x to the fourth?
Oh, okay.
Okay?
X to the fourth, what did you say? So you did something.
Take out.
I didn't do it, John.
For both of them.
Minus 2x.
Okay.
Where's new dog? Negative.
So this one is 0 to 2.
Big R square is like up and down like x, right? Big R. So, and it's revolving around the x-axis.
Okay.
So,
And if you're finding
where's
the
the other
volume,
boundary? How do we find the
you find the big radius, right, center, it's the outside. You find the small radius, center,
Lord.
and your setup is big R squared minus little r.
I really don't know.
At no point
I don't know what I'm doing.
big R minus little r, square the thing, and square them separately.
Alright.
Well, we still did the box.
And there's that.
Yeah, we did.
Do you subtract 2x minus x squared
You would just say
for the
2x
rectangle?
squared. squared? Minus what's x squared? Hi. Eunice, Anthony, and Juan. So Eunice, Anthony, and Juan, you are going with this very good-looking, respectable young man who has a note with your name on it. I don't know where you're going to, but if Eunice is going, I'm assuming it's an okay thing.
It's not fine, look at
Okay,
it.
you don't have a Jose Oliva on here, right?
You say yes.
Okay, good. Eunice, Anthony, and Juan, in the event that you don't come back, please come back. In the event you don't come back, the problem set is due tomorrow, and that's to finish problems 1, 2, 3, and 4. All right. All right, friends, it is time. It is, bye. Jose, hey, hi, back to me. Jasmine, you okay there? Make him do his own work. Okay, we've got 20 minutes left. I want to push your thinking yet again. This is 100% calculator active. Thank you, Christian. Hi, all the side conversations need to stop, otherwise I'm just going to lose my mind. These fake Wednesdays, right? We are also programmed for early release Wednesdays, and when we have like full day Wednesdays, it feels like twice as long as any other.
Yeah, crazy.
I know, but Friday will be good. Friday will be good. All right. So, calculator's out. We got less than 20 minutes. I want to push your thinking as far as I possibly can. So, with that in mind, Ramir, can you go back and drive? I want you guys to take 1 minute, read through this problem, get ready, do whatever you would normally do on your calculator. The take home tomorrow is going to look and feel something like this. I want to do it well so you're set up for success. So this is 1 minute of just silent work time. Who knew I would ever say that in my life, huh? You should be like, Ron Beer, where'd you go now? There is something tricky in part A. I'm curious to see how many of you guys can find it. That's the kind part. Did you find a tricky part? Always a good idea. Graph these things on the calculator. Some of you have already snapped to it. You know what the tricky part is. We've got two different regions, region R and region S. Which one are we spinning?
R.
Region R. The important question is, what are you spinning this around?
Why?
The y-axis. That should strike a little bit of fear in your heart. You guys show me the y-axis? Y-axis is going this way. If your axis of rotation is going this way, then you're spinning this way, right? Not like x-axis and I spin this way. Y-axis, I'm spinning this way. If you're spinning this way, what makes that so hard? dy. Everything is now a dy integral. Your limits of integration in terms of y. The function in terms of y. Everything's in terms of y. Ramir, how are you doing there?
Just setting this.
Okay, that looks good to me. Let's just leave it at that. All right, so spinning around. Ramir, please don't change the window at this point.
I'm not touching it.
I know. I just,
Alright.
once I start writing on this, don't change it. Okay, y-axis. Everything is dy. My advice, like when I was teaching this to the BC kids, as soon as you identified dy, we would always be like, dy! Do it, it's okay, it feels good. Which way? dy!
Karate chop.
Right, it's like a karate chop.
That's you.
All of our rectangles have been going this way before. That's our dx. But now when you draw your rectangles, your rectangular slices, they go this way, dy,
Why?
dy. 2 questions I'm gonna ask you about this little rectangle. I'm gonna ask you, how thick is it? How wide is it? That's the dy. I'm gonna ask you, how long is it? How do I find the length in a dy kind of world? It's right minus left. It's not top minus bottom anymore. So, which one's on the right?
G of X?
G of x?
Yes.
Everyone agrees G of x is the one on the right?
Yes.
No one wants to disagree.
Wait, hold on.
You said left or right?
Which one's on the right?
What did that give you, Tom? G of X.
Yeah.
Everyone seems okay. It's G of x.
I thought it was G of X.
Here's the thing. This is the region that we're revolving. Which function's on the right?
Oh.
Are we
Oh,
looking
is
at
that-
the
Jasmine, what's the issue?
It's, because both of them are on the right, there's no function on the left.
There is a function on the left. The function on the left is the y-axis, but which one's on the right? The answer is, it depends. It depends. Are you up here? In which case, which one's on the right?
G of X.
G of x. Here?
G of X.
G of x. Here.
F of
F of x is the one that's on the right. Because you're switching from like G of x up here to F of x down here. You guys know there's only one way that we're going to be able to figure this out. You need 2 different definite integrals. So your volume, you're going to find the volume of the first plus the volume of the second. Now, where do we make the switch? We make the switch at that intersection point. Okay, so I'm going to label it this way, like here's the volume of the first region, here's the volume of the second region,
Oh, I see.
right? dy, these are dy integrals. Now, easy question. When I take these 2 regions and I spin them, solid or hollow?
So,
That seem pretty consistent. Solid, we're good? So if it's solid, then your setup's not too bad. Pi, integrate, something squared, dy, plus pi, integral, something squared, dy. If I look at this first region, this guy down here, have a quick conversation with somebody near you. What are your limits of integration? Don't tell me, tell them. What are the limits going to be?
The number is 8. So it'll be from 0 to 8.
because dy down.
Yep, start doing your thing. Just don't change the scale or move the graph.
But it's just
It's 0 to 8.
whatever. What else? Yeah, we find the intersection and 0 is equal.
Oh,
Together.
right. My bad. So it'll be from that little point.
0.344.
Like here.
Since it's
So we can need that 8.
the y-axis is going to be from 1 to that point.
All right, seems like most folks are convinced that the limits of integration go from this point over here to this point over here. Right, from that point to that point. Here's the thing I want to make sure we don't get wrong. What's the value here?
1.
Yeah.
1 or 0? Why 1?
It's a y.
Y.
Because it's a dy integral, everything's in terms of y. So your lower limit of integration is y equals 1. Well, where do I stop?
The point where they intersect.
At the point where they intersect. Ramir, did you find the intersection point? Oh, you did, and then you brought it over here.
So you can see.
So 0.3442?
No.
No, 1.4.
Adrian at 1.4108, right? Now, it's been a while. Do I need this 1.4108 for a calculation?
Yes.
Yes, so you could, if you wanted to, you can say 1.4108. But I think you guys know what I really hope you're gonna do. Store that value. Ramir, do you remember how to store? Click on it once, var, store var, call it something. So we're gonna call it A. That's great, A, but make sure somewhere on the side you tell me 1.4108. Great. So we've got limits of integration. Jasmine, you okay? What's the function?
f of x minus y.
What's the function? If we're on this lower part, we're going from 1 to 1.4 or 1 whatever. It's e to the x, but there's a problem. There's a problem. If you tell me that the length here is y equals e to the x, David, do you know what the problem is?
Yes, you have to put it in terms of y.
This is a dy integral. The only thing you can put in here, it has to be in terms of y. So you gotta solve it for x. So, but God, remember there used to be a time this was hard? If y equals e to the x, what's x?
Natural log of y.
X is the natural log of y. You take the natural log on both sides because they're inverses. So it's natural log of y, the whole thing squared. Take a minute, see what you can do with the second one.
I tried to do it.
God, there once was a time that was the hard stuff. Some of you are like, that's still the hard stuff, coach.
No, we do art
But what about the pie? It's always divided. It's divided, right?
Does that mean you can take the pie out? Or we want the egg?
I mean, because you stay with the pie over here, right? So you just divide that one.
Oh.
Yep.
Right?
Yep.
It's like a2y.
So then we have
Is that 3?
Does that make sense?
Alright, so if all goes well, I've seen it on a lot of papers, your limits of integration for the second one are going to go from a to 3. Okay? Right, a is that 1.4108, the 3 is the y value over here. And Marvin, how long are the slices up there? Not Marvin! Martyr, sorry. I thought I was over that in my life.
How long are the slices?
If I'm up here, how long are the slices? What? How long? How long we need to think right minus left? G of x is the guy on the right. The y-axis is the one on the left. And so you might say, oh, well, it's just this y equals, what is it, 3 cosine pi x? But it's a dy integral. So what's the plan?
Solve for x.
Solve for x. And this used to be the hard stuff too. Solve it for x real quick. What are we going to do? We're going to divide by 3. So y over 3 equals cosine pi x. To get rid of cosine, you need to take, what's the inverse of cosine? Arc cosine. Before you're like, but I don't know what the arc cosine is, just make sure that you can write it. It's arc cosine of y over 3 equals pi over x. Solve it for x. X is 1 over pi arc cosine y over 3. So my setup over here that I didn't leave myself nearly enough room, 1 over pi arc cosine y over 3 squared dy. For the most part, if folks feeling okay? Do not need you to type this in the calculator.
Set up.
Because it just says, just go set it up. So here's what I want you to do. If you're feeling good with this, move on to part B. If there is any part of you that is unsure about what we just did, now is the time to ask me the questions. Yeah.
So basically you did the same thing that we usually do, except for instead of x, everything turns into y, right?
And why did that happen?
Because the axis of rotation.
Yep. The axis of rotation is
Y.
Is the y-axis. It's vertical. And so if I'm spinning this way, the rectangles are horizontal, so that's the dy integral instead. As soon as you see dy, everything changes.
Where did the 3 split?
Where did the 3 come from? Oh, for the limit of integration? If you're above this line, right, we start at the intersection point, and you stop at this point up here. And the y value for this curve at this point is 3. Part B's got a completely different challenge.
So did you see your drawing?
I think so. And if you want to change the scale on this, I'm going to erase all this stuff, so do whatever you need to do with the crown. Just like, don't erase it.
Oh, you want me to?
Look at this.
I'm saying, if you want to adjust the window, feel free.
Yeah.
It's
And minus.
f of x minus 0, right?
You need to find the point
And
right here.
this one is revolved around the x-axis.
Oh, yeah, you're right. Would that be plus? Plus here. And then it would be,
What's that point? Do you have a graph ID?
what point? Oh, the 0?
It would be E of x minus.
Hey, Robert, can you adjust this just a little bit so I can see the x-axis?
Yeah. Yeah. I just wrote it with the x and g. So it's 0.5. That is.
Oh, it's going to give you an error. Hit the window again.
The 0? No. Oh,
Yeah, I thought this
oh,
was 5.
Okay, good. All right. This region, right? That's the region. Where's the axis of rotation? It's on the x-axis. This is what I'm spinning around. So the most important question I'm going to ask you now: solid or hollow?
whatever.
Right. If I take this region and I spin it around the x-axis, I'm getting a solid object. Okay. So just about everybody seems to get the right region, you get the right axis, you know it's a solid object. What's the problem? What's the challenge with this one? One person sees it, 2 people see it. There is something challenging in this problem. 3 people see it. If you don't see it, I'm a little worried. Daisy, what do you see?
It's the equations aren't going to be the same because they change.
Okay. All the things you just said are right, but tell me, how do you know that?
Because from like 0 to the intersection point,
From 0 to the intersection point, what's happening with those rectangles?
No, this one
the
will not
f of
be.
x is at the top.
F, right. The length of the rectangle is f of x, and the width is this dx. And what happens at the intersection point?
Then it's gonna be g of x.
Right now, those little rectangular slices are g of x. I know I've said this the last couple of days and before spring break. The slices tell the whole story. If you see that it's f of x over here and g of x over here, in my mind, I kind of draw this just like imaginary line and say, okay, here's volume number 1 that I'm going to work on. Here's volume number 2 that I'm going to work on. Let's set it up real quick for part B. Volume equals pi integral. Where do I start?
0.
0. Where do I end?
0.5.
No, it's to the point 3.
Oh, yeah, my bad.
Right? For
Like
this first one, you
0.344.
go from 0
Hey, my bad.
until the intersection point.
The other one.
Yeah. And this is where you need to be careful. What's the intersection point? It's the 0.3442, right? Because you need the x coordinate. So I'm just going to call it b. Integral from 0 to b. Give me the function. Is that f of x? Squared dx plus pi, the integral from b. Where do I end? Right, this guy over here is at 0.5.
No,
0.5, g of x, the whole thing squared, dx. Lots of points are going to come from do you have the right setup? How many guys honestly have the right setup? Nice. Last point comes in, can you get the right number?
1.891.
And according to my calculations, 1.891.
Mr. D,
Yeah.
couldn't you have just solved for everything using the the red graph and then subtract what we just got from all?
Name one.
Let me think. No. I hear what you're saying.
But if you take out all these, you have.
The problem is, it's this region, like this little acorn piece that's spinning, it doesn't go all the way down.
So it would do a block.
You're gonna get a different answer. So, tonight's homework, 1, 2, 3, and 4. 3 of them are calculator active, so if you can do this, you are set. 1 of them is calculator inactive. That one's gonna be a little bit more challenging. If you're having any calculator problems, just let me know, but otherwise I will see you tomorrow.
This right there.
Yeah, the one from yesterday. Enjoy your benchmarking experience tomorrow.